we might be closer to an ice age than we would like to admit. And the reason is global warming. Yes, I know, not so intuitive. One might ask, what's the most significant consequence of global warming? And the response usually looks something like, oh, nothing much, just the sudden increase in sunscreen sales and polar bears getting their own air conditioning units. But that's not all. The global heating of the Earth disrupting the periodic cycle of ice ages that are naturally caused by its orbit around the Sun and other orbital parameters. Let's see what scientists have to say about what causes an ice age and how global warming might be affecting the upcoming one. What is an ice age? So what is an ice age? It's a geological phenomenon that is both a blessing and a curse, kind of like finding out your favorite guilty pleasure snack is actually good for you. On one hand, it brings forth majestic landscapes of icy wonder, like a frozen fairy tale land straight out of a Disney movie. On the other hand, it also means freezing temperatures that make even the most diehard penguin question their life choices. To put it scientifically, an ice age occurs when the Earth enters a period of time where temperatures drop significantly, causing vast sheets of ice to cover large portions of the planet. It's like Mother Nature's way of saying, hey, how about we switch things up a bit and turn the thermostat down to Arctic? Now, you might be wondering what kind of celestial variations cause the icy spectacle. Let's go through them. Wobbles of Earth. Imagine the Earth as a little spinning top, rotating and wobbling almost like it's trying to make up a dance move. But unlike John Travolta, our planet has less defined rhythm. It sways and turns like an ice skater who is losing balance because of the great variations of its rotation. You see, the Earth doesn't rotate as perfectly as we are taught in school, where we are told that it has an axis tilted at 23.5 degrees from the vertical and it just spins around it. I would have personally loved it if it did just that, but reality is much more complicated, and scientists are losing sleep because of it. So throughout many mysterious variations, we ended up discovering that Earth's spin axis has been shifting towards the east much faster than before. This shift, accounting for almost 17 centimeters per year, is thought to have been caused by the loss of mass from rapidly melting ice in Greenland and Antarctica. But how are these two things related? Well, in easy words, the universe has its way of preserving balance. In the case of bodies that rotate, there has to be a conservation of angular momentum, which in turn depends on the mass distribution of the object and its rotational speed. So when ice sheets melt, the mass is redistributed from solid ice, glaciers, to liquid water in the oceans. And this change could cause a change in the rotation of the Earth. So how do we test such a hypothesis? It's easy. You just point satellites to monitor the changes in Earth's mass over the years. Thanks to the GRACE satellites, we were able to measure the amount of mass included in the cycles of water between land and oceans and conclude that indeed that was causing it. But not only from the poles like we thought, but also from the Indian subcontinent and the Caspian Sea that actually had a bigger impact than we expected. This change in tilt caused by global warming changes the cycles of variations in the Earth's orbital parameters, also called the Milankowitch cycles, and in turn affects when we expect our next ice age to be. If you haven't seen our video on the crazy prediction of the Milankowitch cycles, go check it out. I'm sure you'll like it, but come back here as we have so much to unfold still. Axial precession. To understand axial precession, it's important to consider Earth's shape and the interactions it has with gravitational forces. Another lie they told us in school is that the Earth is a perfect sphere. Well, guess what? It's not a sphere. It's flatter at the poles and has bulges at the equator because of its rotation. This causes an asymmetric distribution of mass and therefore generating tidal forces on the equatorial bulge by the Sun and the Moon. The time it requires to complete a full cycle and go back to the same axial tilt is around 27,000 years, causing one hemisphere to experience more extreme seasonal differences than the other. Did you know that currently the perihelion, which is the Earth's closest point to the Sun, happens during winter in the northern hemisphere and summer in the southern hemisphere? However, in about 13,000 years, this will actually switch. This means that the northern hemisphere will then experience more extreme solar radiation, while the southern hemisphere will enjoy more moderate seasons. It's fascinating to think about how our planet's climate patterns can change over such long periods of time, isn't it? And you won't feel the difference because your lifetime is so much shorter. Eccentricity. The shape of our orbit around the Sun changes over time. That shape is what we call eccentricity, and it varies between 0, giving us a nice circular orbit, and 1, where the orbit becomes more stretched and elliptical, looking more and more like an elongated egg. The blue planet's orbit has a pretty low eccentricity, quite close to 0. But here comes the interesting part. Due to the gravitational interactions of Saturn, Jupiter, and other factors, the Earth's eccentricity can actually vary over time. This means that the shape of our orbit changes, which in turn affects the distance between the Earth and the Sun. And guess what? This variation in eccentricity is the reason why our seasons have slightly different durations. Currently, summers in the northern hemisphere are about 4.5 days longer than winters, and springs are about 3 days longer than autumns. As the eccentricity decreases, the duration of our seasons gradually evens out. A scientist named Milankowitch studied these variations and found something fascinating. When the Earth's orbit is at its most elliptical, we receive about 23% more solar radiation at our closest approach to the Sun compared to our farthest departure. Right now, Earth's eccentricity is near its least elliptical, most circular, and is slowly decreasing over a cycle of about 100,000 years. But don't worry, the change in global annual insolation, the amount of solar radiation reaching Earth's atmosphere due to the eccentricity cycle, is actually very small. Since the variations in Earth's eccentricity are relatively minor, they only play a minor role in the annual seasonal climate variations, and luckily we have nothing to do with it. Combination of the cycles. Now that I can use these terms with the peace of mind that you will know what I'm talking about, let's go through how they could cause an ice age on Earth together. Specifically, combined periods of low eccentricity, a lower rotational axis tilt, and the positioning of the closest approach to the Sun during the northern hemisphere winter definitely create just the perfect environment for an ice age to form. Ocean circulation. The last period of ice the Earth went through was 100,000 years ago and lasted for around 75,000 years. The Earth actually goes through one of these every few million years. Right now, we are in a time called an interglacial period, which means it's not as cold and the previously accumulated ice is melting. After some scientists at Cardiff University studied icebergs that melt in Antarctica, they found that when these icebergs melt, they release pieces of rock into the ocean. These rocks cause changes in the ocean circulation, which is how the water moves around. When the Antarctic icebergs melt, a lot of fresh water goes into the Atlantic Ocean from the Southern Ocean. This makes the Southern Ocean saltier and the North Atlantic fresher or sweeter, causing a change in the ocean circulation pattern. Why does it affect the pattern of ocean's circulation? Well, that is due to the difference in density between freshwater and saltwater. Saltwater is denser than freshwater, meaning that it has a higher concentration of salt and is therefore heavier. When the Antarctic ice released large amounts of fresh water into the Southern Ocean, the flow reduces the overall salt concentration into the Southern Ocean, making it relatively dense compared to the saltier one. As a result, the fresh water being lighter tends to stay at the surface rather than sinking down into the deeper layers of the ocean. This change in density and distribution of water affects the ocean's circulation patterns, specifically the thermohaline circulation. This circulation is driven by differences in temperature, thermo, and salinity, haline, and is responsible for redistributing heat around the globe. This change makes a lot of carbon dioxide, which is a gas that unfortunately makes the Earth warmer and that we are emitting a lot of nowadays, to be taken away from our planet's atmosphere. It reduces the global warming effect and can push the Earth into a new ice age. This is actually exciting news because we have found evidence in rocks that shows how the Southern Ocean and Antarctica play a big role in changing the Earth's climate. Global warming, the ice age's misunderstood cousin. Now, the natural thing would be for you to start thinking is, but shouldn't global warming cause us to melt and not to freeze? My dear, you are indeed correct. Global warming consistently caused by human activities is indeed making the overall temperature of the Earth rise, leading to the melting of ice caps and glaciers. It could trigger natural response mechanisms that could potentially push the Earth into another ice age. For example, more land gets exposed as the ice sheets melt. This land can then reflect less sunlight and absorb more heat. This absorption of heat can lead to a reduction in global temperatures, and guess what? Contributing to the start of a new global glaciation. So while global warming and ice ages may seem like polar opposites, pun intended, they are actually quite connected in a complex relationship of cause and effect. If you think about it, it's actually a nice reminder that even though human activities are currently driving global warming, our actions can have unintended consequences that extend far beyond our initial understanding. However, like every new theory, there are always some scientists that think the opposite. Those ones believe that human-caused global warming may actually delay the onset of another ice age, as rising levels of greenhouse gases in the atmosphere contribute to rising temperatures. How would we react? The past pandemic showed us that humans have developed the ability to create an environment that accepts what it's going through and gets creative with it. I really wonder what our current generation would do if it had to go through an ice age anytime soon, and what creative thing they would come up with. So let's leave science behind a little and have a little fun with this subject. Firstly, I think that the world would very quickly look like a winter ball on steroids. Snow and ice would cover all cities, turning them into giant fantasy snow globes. Cars would probably have to run on something other than wheels, maybe something like skate and ice stoppers. Or is that too far-fetched? I mean, we have to adapt because it will be something that could last thousands of years. Will we have to start over? Fashion trends would revolve around puffy coats and fur trimming everything. Ice fishing would become the latest extreme sport, with competitors battling the icy depths to catch the biggest frozen fish. Ice hockey would reach a new level of excitement as players would have to constantly avoid falling icicles and slippery surfaces. I could keep going. However, despite the challenges, people will adapt and find humor in the absurdity of their frozen world. Ice age-themed comedies and sitcoms would dominate the entertainment industry. Laughter would become the ultimate defense against the cold, and ultimately, laughing does make you sweat. We keep being reminded of humanity's resilience and adaptability and how we would face the freezing temperatures with a mixture of creativity, humor, and lots of warm clothes. And who knows, we might even embrace the icy conditions and adopt a new way of life. Scientists are still not sure when the next ice age will occur. While global warming is currently disrupting the natural cycle of ice ages, it is unclear how long it will take for the planet to reach a tipping point. However, it is important to note that the current rate of global warming is unprecedented in Earth's history. The rapid release of greenhouse gases, primarily by burning fossil fuels, is causing temperatures to rise at an alarming rate. If we continue on this trajectory, the consequences could be catastrophic. Therefore, it is imperative that we take immediate action to mitigate the effects of global warming. Switching to renewable energy sources, reducing greenhouse gas emissions, and promoting sustainable practices are all essential steps to protect the future of our planet. The Ice Age is a fascinating geological phenomenon that brings both wonder and challenges to our planet. From breathtaking icy landscapes to bone-chilling temperatures, it's a roller coaster ride of extremes. And while global warming may seem like its misunderstood cousin, the truth is that our actions today could have unforeseen effects on the delicate balance that keeps our planet in an ice age. So let's strive to understand and protect our planet's geological intricacies, ensuring we don't tip the scales too far in one direction or the other. That's all for this video. Thank you so much for watching. What would you do if you had to encounter an ice age? And what would you like to hear next? Let us know in the comments below. See you next time on the channel.